Hello and welcome to Mathematics with Simon. I'm Simon. So today we're going to look at the subject of factorisation, which is in the A-level maths syllabus. In the last video we looked at expanding brackets. For example, 4 times 2x plus 3y equals 8x plus 12y. I'll put a link to that video in the description. But sometimes we might go in the other direction. So we might ask how we can factorise 8x plus 12y. So what we do is we look for the largest term that divides both. So in this case, 4 goes into 8x and 4 goes into 12y, and there's nothing bigger that goes in. So then we basically can write it this way: 8x plus 12y equals 4 times 2x plus 3y. So this is in a sense just the reverse of this. So what we're doing is we're saying on the right hand side 4 times 2x equals 8x, 4 times 3y equals 12y. So we're kind of taking the 4 out, putting it in front of the bracket, which is kind of the common factor of the two terms. And sometimes the term which is common to both can include a variable. So if you look at 20x squared plus 16xy, we can see that 4x, 4 times x is common to both. So there's a 4 in 20, there's a 4 in 16, and there's an x in x squared and an x in xy. So we can write that as 4x times 5x, because 4x times 5x is 20x times x, which is x squared, and then 4x times 4y is 16xy. So we've taken 4x out as a factor, we've written it in this alternative way. Here's another example: 15ab squared plus 20bcd. So firstly, 5 is common to 15 and 20. And then next, b and c are common to both terms. We've got a b on the left and a b on the right. We've got a c on the left and a c on the right. So we can write it like this. So it's 5bc times 3ac plus 4ad, because 5bc times 3ac is 15. And then you've got a times b, and then c times c is c squared. And then 5bc times 4d, 5 times 4 is 20, and you've got bcd, 20bcd. So we've taken 5bc out as a factor. Now, what use is factorisation? Well, remember quadratics. I mean, we did these at GCSE, but we start with x squared minus 4x plus 3 equals 0. Now, this seems hard to solve because we can't just manipulate it to get x on its own on the left-hand side and then a number on the right. Because however we manipulate it, it seems like we always have too many occurrences of x. We can't just get a single occurrence of x, which is then equal to a number. But what we can do is factorise, and we can factorise x squared minus 4x plus 3 as x minus 3 times x minus 1. Because if we multiply this all out, x times x is x squared, minus 3 times x gives us minus 3x, minus 1 times x gives us minus x. So minus 3x minus 1x is minus 4x, which gives us the x terms. And then minus 3 times minus 1 is 3. So we factorise x squared minus 4x plus 3 as x minus 3 times x minus 1. If they multiply together as 0, that means that either x minus 3 is 0 or x minus 1 is 0, because if two things multiply together as 0, one of them must be 0. So either x minus 3 is or x minus 1 is, which means that either x is 3 or x is 1. And we can check this. If you pop 3 back in, you get 9 minus 12 plus 3, which is 0. And if you pop 1 back in, you get 1 minus 4 plus 3 is 0. If you pop every other single number back in, you'll find it's not 0, but it takes too long to pop every other number back in because there's an infinite number. But trust me, it's true. Never trust a man who says trust me, right? Okay, how about this one? 20x squared plus 16xy over 4x. Well, I think we saw earlier in the video that 20x squared plus 16xy is 4x times 5x plus 4y. So it's 4x times 5x plus 4y divided by 4x. So the 4x is just cancel. We can divide the top and bottom by 4x. So this pretty complicated expression on the left actually boils down to 5x plus 4y, which is much easier to understand, much simpler. Here's a special case. X squared minus 9 over x minus 3. So x squared minus 9 is a classic example of a difference of two squares. So x squared minus 9 equals x plus 3 times x minus 3, because if we multiply out x plus 3 times x minus 3, we get x times x, which is x squared, plus 3x minus 3x just cancels, and then you get plus 3 times minus 3 is minus 9. So x squared minus 9 over x minus 3 is x plus 3 times x minus 3 over x minus 3. The x minus 3's cancel, we divide top and bottom by x minus 3, so we're just left with x plus 3. Should we just put in a version of x to make ourselves comfortable that this works? Let's just put in x equals 4 as an example. So if we put in x equals 4, on the left-hand side, we'll get 16 minus 9, which is 7, divided by 4 minus 3, which is 1. So on the left-hand side, we get 7. On the right-hand side, we get 4 plus 3, which is 7. It works! Hooray! I mean, it works with every number. That's the whole point, right? That's why it's so clever. Here's another special case. X cubed minus 3x squared plus 3x minus 1 equals 0. So actually, this is a bit harder, and to really do this, you have to know the binomial theorem, which we'll look at in a later video. But basically, you can see that this factorizes out to x minus 1 times x squared minus 2x plus 1. And then x squared minus 2x plus 1 factorizes to x minus 1 times x minus 1. So this means that x minus 1 times x minus 1 times x minus 1 is 0, which means that x must have been 1. And when you put x's 1 back in, you get 1 minus 3 plus 3 minus 1 is 0. I think the tricky step here was from the first line to the second line. So knowing that x cubed minus 3x squared plus 3x minus 1 was equal to x minus 1 times x squared minus 2x plus 1. Again, familiarity with the binomial theorem will help, but we can actually just multiply it out, and it's probably good for us, good for our souls. So x times x squared gives us x cubed, and then we get minus 1 times x squared, and we also get minus 2x times x, which will give us minus 3x squared. Then we get x times 1 gives us an x, and minus 1 times minus 2x gives us another 2x, so we get 3x. Then on the back we get minus 1 times plus 1 is minus 1. So that's how it multiplies out. And then x minus 1 times x minus 1 is x squared minus 2x plus 1. That's easier. X times x is x squared. Minus 1 times x minus 1 times x gives us minus 2x. And then minus 1 times minus 1 is plus 1. I really hope you enjoyed this. If you do, please hit the like button. Please subscribe and hit the notification bell. I'm going to be doing more and more of these. I'd love to hear your ideas, and I hope you enjoy your mathematics.